Hi. For number 35, we need to state the inverse of the function using correct notation. Well, number 35 doesn't really tell us what the function's called, so we're just going to find the inverse of this function, whatever it may be, and we'll use a different color. We'll use purple to represent the inverse function, or the inverse of the function. So let's just start by finding the points of the original function. So the original function has points of 0, 6, 1, 1, 3, 5, and 6, 3. Now I'm going to find the points of the inverse function and graph them as I find those points. So to find the points of the inverse function, I just replace x and y. So I switch the position of x and y. So the first point becomes 6, 0. So I'm just reversing the order of 0, 6 to find the point of my inverse function. Then the inverse of 1, 1 is just 1, 1. So that point stays the same. The inverse of 3, 5 is 5, 3. And the inverse of 6, 3 is 3, 6. When I'm going to graph the inverse function, it's important to keep the order that I went, so 0, 6, 1, 1, 3, 5, 6, 3. It's going to be important to keep that order the same when I connect the lines of my inverse function. So the first point is 6, 0. 6, 0 is a point right here. Then we're going to graph the next point, which is 1, 1. And since order is important, I'm going to connect those two points together. And then the next point is 5, 3. So here's 5 up 3. And then from 1, 1 to 5, 3, I'm going to connect those 2 points. And then finally, the last point that I'm going to graph is 3, 6. There's 3, 6. And then I need to connect from 5, 3 to 3, 6. So the purple line represents the inverse of the original function. That's the line in black. And what we notice is that the inverse function is not a function because it does not pass the vertical line test. The original function does pass the vertical line test. Now, for part B, we need to state the domain and range of the function and its inverse. So I'll switch back to black to state the domain and range of the function. So for the function, the domain is the width, or how wide my function is. So the leftmost point is 0 and the rightmost point is 6. So I can write that as 0 is less than or equal to x, which is less than or equal to 6. The range of my function is how tall the function is. So the black line has a low point of 1 and a high value of 6. So the range is 1 is less than or equal to y, which is less than or equal to 6. So there's the domain and range of my function, and the next thing I will do is find the domain and range of my inverse using purple to represent the inverse function. The notation I use is going to be d inverse 1 to represent that I'm now stating the domain of the inverse. One thing that's helpful to note is the domain is just the range of the original function, and I just replace the y with an x. So I can just write this as 1 is less than or equal to x, since I'm dealing with the domain, which is less than or equal to 6. So the numbers of the domain, the inverse domain and the original range, 1 and 6, 1 and 6, it's just the x is different because I'm dealing with the domain, and domain is always my inputs. I'm going to move on to the range. So R inverse 1. And for the range, I'm going to use the numbers from the original function's domain. So 0 is less than or equal to y now, because the range has to do with the y, is less than or equal to 6. Now I could also just look at the function to find the domain and range of the inverse. So the range, just to test that with the range of the inverse, I start at y value of 0, and I go up to a y value of 6, which is exactly what I have right there. So now we've stated the domain and range of the function, as well as the domain and the range of the inverse. Last part says state if the inverse is also a function. Well, just looking at the purple line, which is the inverse, it does not pass the vertical line test, because if I were to draw a vertical line, or roughly a vertical line, I see that my the line goes through more than one point, and so this point, or this line goes through this point on the inverse. It goes through here and here. So those 3 points show that the inverse is not a function. So that answers A, B, and C of number 35. Thank you again for watching.